Hi everyone, today I will be using Malleable from Distorted to make some music. As you can see, I've already started, and so far I've created a 4-channel looper controlled by a sequencer. If we look at the control view, you can see that on the top row I've got my sequencer controls, then I have some mixer controls, and then I have 4 more rows, one for each of my looper channels. In the top right is an oscilloscope, and that's because right here I have a microphone, and if I turn up the gain, you should be able to see the signal. So let's get started and record our first channel. When I click this button, this channel will be armed the next time the sequencer gets to the first bar. Great, let's record the next channel. I guess I didn't arm it properly. Let's try again. One more time. Okay, now that that's in place, I'm going to add some synths. Let's define an oscillator. I'll create a new block called OSC, and I'm going to give it an input for the frequency and an input for the gate. I'm going to give it a buffer for the actual frequency, and I'm going to give it a buffer for the output of the wave function, and finally an output for the audio. I'm going to set the buffered frequency to be the input frequency whenever the gate is non-zero, and I'm going to set the wave buffer using a wave function which will output a square wave based on the buffered frequency. Great. And then I'm going to set my output audio by multiplying the wave buffer by an attack release envelope triggered by the input gate with 300 milliseconds of attack, and we'll do 2 seconds of release. I'll divide that by 100%, and I'm actually going to multiply it by 0.1 to make it real quiet. And I'm going to filter this square wave using a low pass filter at 2K with some resonance as well. Great. So let's use the OSC block definition and create an oscillator called OSC1. And I'm going to send the first MIDI voices frequency to OSC1's input frequency. And I'm going to send the first MIDI voices gate to OSC1's input gate. And finally, I'll send OSC1's output audio to the next input on my mixer. I'm going to turn the volume down, save my changes, show the MIDI pane, and play a note. Great. Okay, it sounds out of tune, and that's because my instruments aren't perfectly tuned to A440. So I'm going to multiply, in fact I'm going to divide this input frequency by a global called detune, which I set up earlier, which will basically bring it in line. Great. And I'm going to reduce the volume a little bit more and give it a slightly longer attack time. Cool. And let's reduce that filter a bit more. Cool. Cool. I want some bass, so I'm going to add another oscillator called OSC2. And I'm going to trigger that using my sequencer. In fact, I'm not going to trigger it, I'm just going to set the frequency using my sequencer. So I'll add an output called out frequency 2. And for now, I'm just going to set that using the note to hertz function to be a C2. So I'm going to send sequencer's out frequency 2 to oscillator 2's input frequency. And I'm going to send a value of 1, because I want it to play constantly, to oscillator 2's, not 1, oscillator 2's input gate. And I'm going to send oscillator 2's output audio to the 6th and final input on my mixer. Let's turn that volume down and save my changes. Great. And let's change the note in the 4th bar to a G. Let's go down an octave. And let's get a little bit more rhythm. I've used all my mixer inputs up and all my looper channels, so I'm just going to send a signal out to my Eurorack. I've got a bass drum module I can use that's already connected. So we're going to add a new buffer called buffgate 3 and an out called outgate 3. And we're going to set buffgate 3 to be 0, but for now let's just set it to be 1 whenever the input tick is high and our subdivision is number 1. And then we can use that. There we go. Then we can use that to set our outgate 3 using an attack decay envelope. Like that. Cool. So let's send. I'll keep things consistent by doing it down here with my other sends to my outputs. Let's send sequences outgate 2 or 3 even to the 9th audio channel, which is connected to my Eurorack. Oh, we can hear it. There we go. We change the sound a bit. Great. I'm going to make the pattern just a little bit more interesting. I'm going to set the gate to also be 1. When the tick is high again, when we're on the fourth subdivision, but only when we're on the third beat. So cool. All right, I'm happy with that. So there's something I want to show, which I think is really fun. If I play a key right now, you can see down here in the MIDI pane that MIDI voice 1 is showing that I'm playing a C5 at a velocity of 2. I'm not actually using the velocity at the moment. But also the aftertouch, pitch bend, and slide are all set to 0. Well, let's actually, this keyboard here is capable of sending a lot more information. To take advantage of it, I need to enable MPE. And to do that, I need to change my poly mode. So I'm going to change my poly mode to MPE low, save my changes, and at the moment, nothing will be any different. But if I play a key, you'll see, if I press down hard, the aftertouch increases. If I go from right to left, there's a bit of pitch bend. And if I slide up and down, the slide value is going from 0 to 127. So the first thing I can do, which is a little bit crazy, is instead of sending V1F to my oscillator frequency, I can send V1X. And what that does is it takes the frequency and it bends it according to the pitch bend. So that's kind of neat, but that's not actually what I want to do right now. So I'm going to go back to V1F. But what I would really like to do is use the slide to control the cutoff of my filter. So I'm going to add another input to my oscillator definition called input cutoff. And this is going to have a minimum value of 0 and a maximum value of 127. I'm just going to give it a default value of 10 for now. And then what I'm going to do is add another buffer called buff cutoff, which will be the actual cutoff for my filter. So then I'm going to set my buff cutoff. Actually, that's not true. It's going to be the input cutoff whenever the input gate is high. Right, that's what I meant to do. So now my buff cutoff, when the gate is high, will take the input cutoff and store it. And so now what I'm going to do is change my filter. So instead of it being set at a cutoff of 1 kilohertz, it's now set at 100 hertz plus the buffer cutoff divided by 127, which is its maximum value, times, and let's do like 3K. So we're going to go from 100 hertz up to 3.1 kilohertz. Okay, you could hear that the bass lines are softened a lot, and that's because the cutoff is massively reduced. So I'm going to increase this default to say 40, maybe 50. That works. Let's go a little bit higher. Cool. Now, if I play a key, it will have the same amount of cutoff. But what I can now do is send V1S to oscillator 1's input cutoff. And let's try that. Let's make it a little bit more drastic. Let's go up by, say, 6K, and I'm going to reduce my default down to 30 for the bass line. Cool. And obviously I could incorporate that, I could incorporate the aftertouch with that, or the pitch bend too. So if I go back to my V1 export, let me turn the volume down just a little bit for this high note. Great. Well, thank you for watching. I hope you like what you've seen. If you'd like to know more about Malleable, please visit the Distorted website.